A ball moving with a momentum of 5 kg meter per second. Wait, a ball moving, okay. Spikes against the wall at an angle of 45 degree and is reflected in the same angle. Calculate the change in momentum. So we have a wall, say this is the wall. We have an we have a ball over here at 45 degree. It bounces off something like this. So the momentum over here is 5 kg meter per second, and here it is 5 kg meter per second. So but against the wall at an angle of 45 degree. So this is 45 degree and this is again 45 degree. Now we are trying to figure out what is the change in momentum. So for this we need to resolve the vectors. So if I consider up and right as positive, then we have, say, this line. Along this line what happens, and along this line what happens is the question. So I'll go the lengthy version, that is I'll take part by part, break it down and show it to you guys. So first is we'll talk about initial momentum. So P of I of x is what we are looking at. So we have it going to the left. So we have it to be 5 and cos of 1 by root 2, sine of 1 by root 2 actually, but both are equal, so doesn't matter. So basically this is minus 1 by root 2 kg meter per second. Then we have P of F I of y, the momentum along the y-axis. This is positive. Why? Because it's going up. Sorry, I didn't make it clear. This is negative because it's going left, right? And along the y-axis it's going up. So this will be 5 root 2 kg meter per second. All of this is to do with initial momentum. Now we have the final momentum. So P of f of x, which is equal to, so final momentum. So we have along the x-axis, we have the we have it pointing towards the right. So we have 5 by root 2 kg meter per second. Then we have P of f of y is equal to, so post bouncing off, the object still continues to go up. So this will remain the same. Okay, again guys, this should be the line of thinking. This need not be the detail to which you write. So we need to figure out the impulse, right? Calculate the change in momentum. No, we're just looking at change in momentum. So final minus the momentum initial. So change in momentum involves final. This is along the x-axis and this is along the y-axis, minus this is along the x-axis and this is along the y-axis. So we have this and this to be cancelled, and this is 10 root of 2 I cap kg meter per second. So as you can see over here, it looks like nothing much is changing, but there was a force applied. How can you tell? Because there is change in direction. An object which was going left and up is going right and up. So there was a force that was applied. So there is a change in momentum, and that's what we are trying to figure out. right? So, and we did that. So the momentum change happens only along the x component. Y component continues to still go up, so that is not changed. And so we have only I cap that is taking part in this entire thing. So you can rationalize this and write this as 5 root 2. Actually, you should do that. This should be written as 5 root 2. If not, in theory exams, you will not get marks. Rationalization is what is expected. So you can do that. Okay, guys. So this is it.